So, with some of these more advanced programming concepts, I have noticed, and this is also an example for myself, that it may be difficult to understand them just by looking at the code straight out from the get go. And again, I know I had this problem when I started learning both of the concepts in this chapter. So, I think it would be beneficial if first, instead of just talking about code, I went in and discussed a concept of why we have this idea in programming and what we use it for, and then we can talk about the code. So this video is all about pointers, and it should be relatively short because pointers are, once you know what they're for, are relatively straightforward. So let's take a look at our example. So we have three very avid high school students, and they all want to start a club. So they all have a sign-up sheet for this club. However, our situation strays from reality in this case, in that each of these sign-up sheets are owned by that person. They cannot let the other people see them and make changes to them, unlike you would in real life, just for the purposes of this example. But the problem is, all of these students want to join one of the other person's club, but they can't do that the way you would normally expect to do it. So, what are the options available to them to solve it? So, they could get a copy of the sign-up sheet, which is okay, but the problem with that is the changes that you make to that copy don't carry through. So, if you sign your name on the copy, you're not signing yourself up for the club, so that doesn't do you any good. They could steal the sign-up sheet from its owner, but that would make everybody mad, and chaos would ensue, and that's not good either. Or they could do nothing. But they were trying to sign up for the club, so that doesn't do them any good. So, what if there was another option? And that is where our pointer example comes in. Instead, they have a new option to get a magical remote copy of the sign-up sheet. What exactly I mean by that? Any changes they make to this copy immediately carry through to the sign-up sheet. It's almost as if that copy wasn't there. Like, those changes that they make to that copy are not saved on this magical remote copy. They go directly to that sign-up sheet. And so, this is the idea in programming of what a pointer is. So now that you've looked at the concept of pointers and hopefully understand it better, we'll look at how they appear in the code. So, this example will be pretty short because there's not a whole lot we can do with pointers alone. You'll see a lot more pointers when you start working with classes and moving variables between classes. So we need something to point at. So we'll just make an integer, and then we need a pointer. So if you remember back to our concept, the pointer itself is actually just an address, so that magical remote copy is just the address of the sign-up sheet. So when we made changes using the right method, of course, to our magical remote copy, they just carried over into that sign-up sheet. So in order to create a pointer in the code, you give it the name, you give it the data type of the variable you're trying to point at, followed by an asterisk, and then you just give it a name like any other variable. Now, to make it point at x, we need to use something called the reference operator, or the C++.com calls it the address of operator. This is an ampersand, and you put it before the variable you're trying to create a pointer for. So point x is our pointer variable. We need a pointer to x. So we use ampersand x. And then that will point x at the variable x. And once you've done that, when you dereference the pointer, which I'll show in a minute, any changes you've made to x will show up in that pointer. So, let's say, just some simple math, we'll make x 6, and then add 2 to that. So x is 8, and we'll see that in a minute. Another thing I'd like to show is that you can pass pointers as parameters and functions. So, print pointer. just by writing it out like any other declaration. And if you want to refer to the variable that's being pointed at by the pointer, so you want the value, not the address, you need to use the dereference operator, which is the star, and you put that before the variable name, and that will get you what that pointer is pointing at. And since we already said that we wanted a pointer for our function, we'll just call our function. Nope, that's wrong. And just pass it our pointer. Okay. And if we run it, it gives us 8, which is right. Now, it also isn't necessary that your pointers point at a variable that you've already declared. So, how we do this is through something called dynamic memory. So if I go through and get rid of all of this, okay. So how we do how you do this is basically you create an integer without giving it a name. You do this using the new keyword. So you say, I'm going to create a new integer. And what this will do is that this will pass, this will create an integer in memory and then pass a pointer to that integer, to this pointer variable that we have declared here. And so after that, you would treat it just like you would any other pointer. So we can do the same math we did on the last one. Have it equal to 6. Point x plus equals 2. So build that and run it, and it still prints 8. So and the nice thing about dynamic memory is that you don't have to keep it pointed at the same variable all the time, but you just need to make sure you free up the space that you used when you created a new integer. So when you do that, you use the delete keyword and you pass it the pointer, and it will delete what is pointed at by that pointer, but it will not delete the pointer itself. The pointer will now just not point to anything. And so after that, we can use it to create another integer. This time, have it equal to 100. So you need to be cautious about when you use these methods. When the pointer goes out of scope, usually the allocated memory will be deleted automatically. But if the pointer doesn't go out of scope after the end of this function, you need to make sure you're deleting your pointer, just to make sure you're keeping your memory sane on your computer. So build that and run it. So now it says 8 and 100. So that is pointers and dynamic memory. The next lesson is classes.